Hi there, in this video I'm going to do a revision question on numerical methods. So let's take a look at this question. Question number 1, part A. By sketching the line y equals x plus 7 and the curve y equals an eighth x to the power 4, show that the equation x to the power 4 minus 8x minus 56 is equal to 0 has two real roots. So let's think about how to do this question. Let's get back to the paper and pen. So we have these two equations and we need to show that this equation here has two real roots. Now this equation was found by equating these two. So if you equate these two, so let me do this in red. If I equate x plus 7 to 1/8 x to the power 4, and if we rearrange this, this is how this equation has been derived. So if I multiply throughout by 8 over here, so by multiplying by 8 times x is 8x, 8 times 7 is 56, that is equal to 8 times 1 over 8 will be 1, leaving us with x to the 4. And if I bring all of the terms to one side, so if I bring these two terms to the right, we're going to end up with the equation x to the 4 minus 8x minus 56, and that's equal to 0. So that is how this equation was derived. Now what is the point for me going through that? The point being is that if we can sketch these two curves on one diagram, the points of intersection of these two curves corresponds to the number of roots for this given equation. So let me go to this screenshot to remind you of that result. So this is the result that I'm talking about. If you have two curves y equals capital Fx and y equals capital Gx intersecting n times, therefore the equation fx equals 0 has n roots. So if we go back to the paper and pen, so if we sketch these two curves, y equals x plus 7 and y equals 1 over 8 x to the 4 on one diagram, the number of points of intersection of these two curves corresponds to the number of roots. Now I have done that on a program called Desmos, so let's take a look at that screenshot. So I have the curve y equals 1/8 x to the power 4 drawn in red, and I have another curve showing the line y equals x plus 7 drawn in blue. And I want you to take note that there's 2 points of intersection here. So I've highlighted these 2 points of intersection on the figure. And remember, according to the results, 2 points of intersection corresponds to 2 roots. So that completes part A. Now, if you're not sure about this result, I have created a video explaining the result in detail, and also there's added examples in that video, and I'll provide a link to that video in the description below. So we have 2 more parts to do. Let's have a look at part B. So part B is we need to show that there's a positive root between x is equal to 2 and x is equal to 3. So let's see how this is done. Let's go back to the paper and pen. So we've been given an interval x is equal to 2 and x is equal to 3, and we need to show that x to the 4 minus 8x minus 56 is equal to 0 has a positive root lying in that interval. Now there is a rule known as the change of sign rule. So if you're unaware of the change of sign rule, I have created a video on the change of sign rule, and I'll provide a link to that video in the description below. But let me talk to you about the change of sign rule. So the change of sign rule says that, now supposing we have this equation of the type fx equals 0, and if we have an interval a and b, so you can either have an interval like this, or you could have 2 values of x being given, as in the question that we've been given in part B. So in part B we've been given 2 values of x. So if you have 2 values of x, or if you've been given an interval, what we need to do is we need to calculate f of these values. So you need to calculate f of a as well as f of b. And if there is a sign change that takes place, so in particular, if f of a is greater than 0, or if f of b is less than 0, or vice versa, that implies that a root exists within the given interval. So let me show you in relation to this problem. So Rf of x, so if we make the comparison, Rf of x is this term on the left, so it's x to the 4 minus 8x minus 56. Let me calculate f of, in this case, 2 as well as f of 3. So firstly, f of 2, simply if I replace the x's here by 2's, I'll have 2 to the power 4 minus 8 into 2 for x minus 56. And if you calculate that, f of 2 should be negative, you should get negative 56. So f of 2 in this case is less than 0. Let's also calculate f of 3. So f of 3, replacing the x's here by 3's, gives us 3 to the power 4 minus 8 into x replaced by 3 minus 56. And if we calculate that, you should have an answer of plus 1 being greater than 0. So as I said, the change of sign rule states that if f of one of the values is positive and if f of the other value is negative, that means that there's a root that exists within the given interval. So in this very example, f of 2 is less than 0 and f of 3 is greater than 0, so that means that there's a root between our values 2 and 3. So let me close by saying, since f of 2 is less than 0 and f of 3 is greater than 0, so therefore a root exists between x is equal to 2 and x is equal to 3. So that should be the solution to that part B. So we have another part to do for part C. Part C is to use the iterative formula. So the formula given is xn plus 1 is equal to a fourth root of 8x plus 56, and we need to start from x equals 3 in order to find the value of the positive root correct to 2 decimal places. So let's see how this is done. Let's get back to the paper and pen. So here is the iterative formula, and here is the value that we start from. Now I usually call that value x0. So x0 is the starting value of the process. And what we need to do is we need to put x0 into our iterative formula to calculate x1. So let's do that first. So if I put in x0 into the formula, I'll get x0 plus 1, which is x1. And if I replace here, I'll have the fourth root of 8 x0, which is 3, plus 56. So if you plug this into the calculator, the fourth root of 8 into 3 plus 56, we should have an answer of, so let's write down the answer. Let's write it down initially to 6 decimal places. So you should get 2.990698. So this is the answer to 6 decimal places. So I would encourage you writing it to 6 decimal places when you calculate the consecutive values, or even better, use the whole value in the calculator to work out the consecutive values. So when it comes to the iterative process, to work out the next one, we need to put the whole value of x1 into the iterative formula. And when we do that, we're going to have x1 plus 1, which is x2. x2 will be the fourth root of 8 into x1 plus 56. So a quick way to do this is, if you haven't touched your previous value that you had, so here's my previous value that I had for x1, what you can do is you can press that back button. So if I press the back button once, and if I, instead of having that 3, if I delete that 3 and put ANS and press equals, this should be the next value. So the next value is 2.990002 to 6 decimal places minimum. So let me copy that down, 2.99000, so 1, 2, 3, 4, 5, 2 to 6 dp minimum. Now, when do we stop the process? We stop the process when the consecutive values of x are the same, and if we go back to the screenshot, we need to continue the process where they're the same to 2 decimal places. So 2 decimal places in this problem is the desired degree of accuracy. Now, let's go back to the paper and pen. So let's round these two, and if these two consecutive values of x are the same to 2 dp, we stop. So over here I have 2.99, so 2.99 to 2 dp. Over here we also have 2.99 to 2 decimal places. This is where we stop the process. So x is roughly 2.99 to 2 decimal places. So remember the idea of the iterative calculation. You keep on calculating values of x, and you only stop the process where the consecutive values of x are the same to the desired degree of accuracy of the question. So that is the solution of part C. Now, if you're unfamiliar with the concept, I have created videos on the iterative method, and I'll give links to those videos in the description below. Other than that, this ends the question, and that sadly ends this video. So I hope you enjoyed the video. I hope you found this video helpful. If you did enjoy the video, a like rating is greatly appreciated. Do plenty of practice problems, and I hope to see you again. Thank you.